To get information about songs in an album, we're going to use the lookup endpoint again. The only difference this time around is instead of the album entity, we're going to specify song. So back in Postman, we'll copy the base URL. So from here, we're going to get everything up to lookup again. And in a new tab, we'll paste this in. And like with the album, the way we're going to search for a song is to provide an ID to look up. Instead of an artist ID, we're going to provide the ID of an album, which back in our response here, if I hit send to get that again, and then load this into JSON. So if we look here, we have a collection, which is an album, and it has a collection ID. So let's copy this and grab the collection ID for the first album. And then back in our final request in our lookup, we're going to specify here under params an ID, and we'll paste in that value. And then for the entity, we'll say song. Done and done. Okay, let's hit send. Again, we'll have to switch this to JSON. Just like before, we have a results array with nested dictionaries. And like the album query started off with a dictionary that contained information about the artist, the first item in the results array for the song query is a dictionary containing information about the album. Now, we're not going to use any of this data, though, because on the final detail page, we're going to use the album class as our model, and we already have this information. So what are we going to get? Let's scroll down to the next section. Here, we have a dictionary that represents a song. So the wrapper type is track, and the kind is song. And there's a lot of information here. We're going to keep it simple, and we'll use the track ID, the track name. We'll also grab the track's censored name. We'll get the track time down here, which is in milliseconds, and then finally whether the track is explicit or not. If you want any of the other info, go for it. So now let's jump back to Xcode, and in the song struct we created earlier, let's add these relevant stored properties. So ID, type int, name, string, censored name, also a string, let track time, this is an int, and finally, whether the track is explicit or not, and that's a bool. Now, one thing I want to point out are types, so album, song, and artist, all have stored properties that have the same name. So we have an ID here, we have a name here, and in our JSON response, these have different names, so collection ID, artist ID. The reason we're not using those names in here is because the type provides some name spacing. So when I refer to this property, it'll be song.name or artist.name or album.name. So there's already that meaning there, and I don't have to give some redundant information in the stored property name. We don't want album.albumName, for example. Now, since this is a struct, we get the member-wise initializer, so we don't need to type one out manually. And with that, we have all our models. So now is the interesting bit. Let's use these models to create some faked data to use as a stub in our app. What's a stub? Well, in this context, it is some code that we can use as a stand-in for actual functionality. Eventually, we want data from the web and to use that data in our UI. But just for the sake of setting up our UI, getting real data involves a fair bit of work. We need to model our endpoints, we need to write networking code, we need to parse the results, and so on. By using fake data, we can immediately start building the UI and getting something bare bones up on the screen. We won't run into any errors with the data because it is a placeholder that we define. And then once we're done with the UI, we can circle back and figure out how to get real data, which is a separate problem on its own with its own set of complexities. So let's add a final file to this models group. We'll call this stub. And in here, we're going to model a fake response in exactly the same way we expect to get back from the web. So we'll start with a struct, and we're doing this just so that we have some namespacing again. And the stub is going to be a simple struct with a series of computed properties. For example, we'll start with artist, static var artist of type artist. Now, in this property, let's return an instance of artist populated with data that we can grab from the JSON response in Postman for looking up an artist term. So we'll say return artist, and then you can go over to Postman, and in this first response here where we look up an artist, let's grab the JSON, and here we'll grab some data from the first result. So We want an artist ID, so we'll copy that. And the rest of the stuff I can just type out myself, so I'll paste this in. The name is Taylor Swift. Primary genre is pop. And the albums, well, an empty array for now. When we search for an artist term, even though our model contains a stored property for the albums, the actual JSON response doesn't have any of that information. We already know that. To get this, we need to make that second lookup call. So here we're just going to return an empty array for the albums. And this is what I mean in that our stub will model the exact same response as our web request. When we get an artist for the first time, albums will be empty, so we need to do some additional work to get the album value. Okay, so that's it for artist. And next is an array of albums. Again, this is a bunch of copy pasting, so you can either do it on your own, go back and forth between Postman and get the relevant data, or just grab the code from the snippet in the teacher's notes. That snippet includes all of the stub data, so you can just simply paste it all in. Let's take a break here. Over the next set of videos, we'll get our entire UI up and running to display all of this fake data.